When VNAV engages, the FMC commands pitch and autothrottle modes to fly the vertical path shown on the CDUs. The profile includes climb, cruise, descent, and speeds. It can also include waypoint altitude constraints. To use VNAV, the Autoflight system must have an FMC path to follow. VNAV speed holds the FMC target speed. This speed is shown by the airspeed cursor and on the CDU climb or descent pages. VNAV path uses pitch commands to follow the FMC altitude or descent path. If the airplane climbs in VNAV, the autothrottle sets the FMC supplied climb thrust. The autopilot maintains the FMC airspeed with pitch. Notice the MCP IAS Mach display. Because the FMC controls the target speed, this window is blank. In cruise, the autothrottle maintains the FMC target speed and the autopilot maintains the FMC altitude. If you select a lower MCP altitude, the AFDS arms to automatically start descent when the airplane reaches the top of descent waypoint. In a VNAV speed descent, the autothrottle sets the thrust to idle and the autopilot holds the FMC target speed. In a VNAV path descent, the autopilot commands the airplane to follow the FMC vertical path. The autothrottle holds idle but can command the FMC speed mode if ground speed is too slow to follow the FMC vertical path. In this example, the FMC route has a cruise altitude of flight level 350. ATC tells you to climb and maintain 15,000 feet. Set 15,000 in the altitude window. Push the VNAV switch to engage VNAV. The FMA shows you that VNAV speed is engaged as the pitch mode and that N1 is the autothrottle mode. At 15,000 feet, the airplane levels off. VNAV has disengaged because you captured an MCP altitude that was different than the FMC cruise altitude. ATC now clears you to flight level 350. Set the new MCP altitude and engage VNAV. The airplane again climbs in VNAV speed. At flight level 350, the airplane again levels off. The FMA changes to FMC speed and VNAV path. The airplane can automatically follow the descent path if you have set the MCP to a lower altitude before you pass the top of descent. To help you, the CDU scratchpad message, Reset MCP Altitude, is shown. Set a lower altitude on the MCP. The airplane descends in VNAV path. The autothrottle sets the thrust to idle. If the winds change the ground speed until it is too slow to follow the FMC path, the autothrottle adds thrust to follow the descent path. If winds change the ground speed until it is too fast to follow the FMC path, the Autoflight system pitches down to follow the path. And the CDU scratchpad shows the message Drag Required if the airspeed increases to more than 10 knots above the FMC target speed. If ATC tells you to change airspeed during VNAV flight, it can be difficult to do so quickly. In VNAV modes, the speed targets come from the FMC, the IAS Mach window is blank, and you cannot change the speed with the MCP. To quickly change speeds, engage a different pitch mode and use the MCP speed selector to set the new target speed. For level flight VNAV legs, engage altitude hold. When altitude hold engages, the IAS Mach window changes from blank to the current speed. Set the new target speed. For VNAV climbs or descents, engage vertical speed or level change and set the new speed. You can also make airspeed changes in VNAV flight with speed intervention. Speed intervention is discussed in another lesson. When the airplane flies in VNAV, the Autoflight system will obey speed and altitude constraints attached to the flight plan waypoints. This is a powerful feature of VNAV and can make arrivals and departures easier to navigate. But if ATC asks you to delete an altitude constraint or change an airspeed, it can mean that you have to program the FMC when you should be looking for traffic. You can use speed and altitude intervention to make these changes. Speed and altitude intervention work only when VNAV is engaged. In VNAV, the MCP IAS Mach display is blank, and you cannot change the speed with the MCP speed selector. When you push the speed intervention switch, the IAS Mach display window will open to the current FMC target speed. The target airspeed line of the CDU shows that the MCP controls the speed. You can now change the speed using the MCP speed selector. The target speed is now 0.78 Mach. If you push speed intervention again, the IAS Mach window blanks and control of the target speed returns to the FMC. You are flying the KLAX loop departure. The FMC shows altitude constraints at kegs and coupe. The altitude constraint of 13,000 feet for kegs is in the MCP altitude window. ATC tells you that the constraint at kegs is deleted. Because there is still a constraint at coupe, enter 15,000 feet into the MCP altitude window. When you push altitude intervention, the constraint at kegs erases. If the MCP altitude is above the constraint altitude, each push of altitude intervention removes one more altitude constraint. The airplane levels at 15,000 feet to obey the FMC altitude constraint at coupe. ATC now clears you to your planned cruise altitude of flight level 350. If the airplane is at an FMC altitude constraint, altitude intervention lets the airplane resume the VNAV climb. Here the climb will continue to the flight level 350 cruise altitude. ATC clears you to a new cruise altitude of flight level 390. Set the MCP altitude to 39,000 and push altitude intervention. Continue. If the MCP altitude is above the FMC cruise altitude, the FMC cruise altitude increases to the higher MCP altitude. Here you are in a VNAV path cruise. ATC now clears you to flight level 410. Set 41,000 in the MCP altitude window and push altitude intervention. Continue. The FMC cruise altitude changes to match the MCP, and the airplane begins a cruise climb to flight level 410. If you set the MCP altitude below the current FMC cruise altitude and push altitude intervention, the airplane begins an early descent. You cannot set a lower cruise altitude with altitude intervention. Continue. In this example, the airplane flies the red-eye arrival to KLAX. There are many altitude constraints on this arrival. In the descent to Civet, the MCP altitude window shows 14,000. ATC removes the altitude constraint at Civet. Set the next lower altitude constraint and push altitude intervention. Continue. The constraint at Civet erases. ATC now removes the constraints at Bindi, Bassett, and Downey. Use altitude intervention to remove the constraints. Continue. 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 If all altitude constraints are removed from a VNAV path descent, the FMC automatically changes to a VNAV speed descent. ATC clears you to 6,000 feet and removes the altitude constraint at Santa Monica. Continue. Push the altitude intervention switch. You are 5 miles behind slower traffic. ATC tells you to slow to 250 knots for separation. Use the AFDS to slow the airplane. You are in level flight at 9,000 feet. Autopilot A is engaged, but no pitch mode is selected. Engage an AFDS pitch mode. ATC has cleared you to descend and maintain 8,500 feet. Use the AFDS to descend. You are in a descent to 8,000 feet when ATC tells you to hold your present altitude. Use the AFDS to stop your descent. The airplane levels off at 8,600 feet. Reset the MCP to stop the altitude alert. ATC clears you to descend to 10,000 feet. Use the level change mode. ATC tells you to reduce your descent rate to 500 feet per minute. Use the AFDS to set a 500 feet per minute descent. ATC clears you to descend to 8,000 feet. Use the vertical speed mode to descend. ATC tells you to maintain your altitude for traffic. Use the AFDS to level off immediately. The FMC has a route with a cruise altitude of flight level 330. ATC clears you to climb to flight level 330. Use VNAV to climb to the cruise altitude. You are in VNAV cruise flight, and ATC tells you to slow to 0.72 Mach for separation. Use speed intervention to slow the airplane. You are in VNAV cruise flight, and ATC clears you to climb to flight level 370. Use altitude intervention to change the cruise altitude. You are on the SATI arrival to KLAX when ATC tells you to descend to 10,000 feet and delete the altitude constraint at Simon.